Hi, now we are at the end of the topic chapter 1, which is the integration of inverse hyperbolic functions. This is the integration formula for inverse hyperbolic functions, where we have 5 integrations and 6 solutions. Okay, for the first one is if the fraction is in this form, then it will produce the inverse sine hyperbolic, and if the integration is in this form, it will produce inverse cos hyperbolic. But for this case, there are two solutions depending on the conditions of the u and a. If u square is less than a square, so the final answer would be inverse tangent hyperbolic times with 1 over a. But if u square is greater than a square, then the final answer will be 1 over a inverse cotangent hyperbolic u over a. And then I'm going to show you the example for this case, okay, so that you can understand how the form of the question for this type. And for this form, it will present the inverse secant hyperbolic, and this is for cosecant, inverse cosecant hyperbolic. Let us try this example where you have to evaluate the following integrals. Now let us try the first example. Given that you have to evaluate the integration of dx over square root of 25 plus x squared. So if you notice here, it follows the first formula where a square is given as 25, and then our u square is equals to x, so u is represented as x, so a is equals to 5. Then we just use the formula of the integration of this, where it is equals to the arc sine hyperbolic inverse u, which is x, over a, where a is 5, plus c. So it's just as simple as the inverse trigonometric functions. The next question is the integrals of dx over 4 minus x squared, and given the condition is the modulus of x is less than 2. So there are one formula which will give you two answers based on the conditions of this. So this one, first let us identify which one is a. So our a square is equals to 4. Therefore, a is equals to 2. We represent u as x here, okay, and then which answer should be in our case? If you notice here, x is less than 2, meaning that our x, which is x squared, using this condition, it is less than 2 squared. Our a square is 4. So means that it follows the first answer, where this results into 1 over a, which is 2 arctangent hyperbolic u, which is x, over a, which is 2 plus c. I have shown you the example of the integration of inverse hyperbolic function. So now I want you to pause this video and then try to do these two questions, and once you have finished, you can play this video and check your solution. For question C, the evaluation of the integration of dx over square root of 2x squared minus 4x plus 5, given the lower limit is from 1 to 4, will give you this answer. So let us show that the integration of this will result in 1.1514. So first, if we notice here, the equation here is in terms of this. So we need to simplify the expression into a simple algebraic expression, so that we can have the equation in terms of x and constant only. So in order to do this, we use the completing the square. So first, what we need to do is we take out the constant of x squared. This will be x squared minus 2x plus 5 over 2. Then we proceed to the next step, which this will be our b and c. So the next step is to plus the b, where b is negative 2, divided by 2 square, and minus with b, which is negative 2 over 2 square, plus c, which is 5 over 2. Then we can factorize this, where x minus 2 over 2 is 1 square, minus with this minus 2 over 2 is minus 1 square, will be minus 1 plus 5 over 2. This can be simplified as 2x minus 1 square. So negative 2 plus 5 is plus 3 over 2. Now our integration of dx over square root 2x squared minus 4x plus 5 can be represented as this simple equation. So we just substitute this all, where this will be square root of 2x minus 1 square plus 3 over 2. Then we simplify this, where we take our square root of 2 outside. Then the remaining is x minus 1 square plus 3 over 2. Now we have the form of this form, where it is in terms of this one, where our a square is equals to 3 over 2. So a now is equals to 3 over 2. And then our u square, our u is equals to x minus 1. So if we differentiate this, we get du is equals to dx. I have rewritten the previous calculation into the new slide. So we have a is equals to 3 over 2, and our u is now is x minus 1. So now this will be equals to 1 over z2. The integration of this will be dx is now is du over square root of x minus 1 is u plus 3 over 2. So the integration of this results in using the first formula where it becomes sine hyperbolic of inverse where u over a, where a is equals to z3 over 2 plus c. Then we substitute u with x minus 1. So this become inverse sine hyperbolic of u, which is x minus 1 divided by square root of 3 is plus c. Now we have solved the indefinite integral. So our next step is to substitute x with 1 and 4. So dx over z 2x squared minus 4x plus 5 from 1 to 4 is equals to 1 over z2 of sine hyperbolic inverse times with square root of 2x minus 1 divided by z3, where the interval is from 4 to 1. So we substitute 4 into x minus with x equals to 1. So we have 1 over z2 sine hyperbolic inverse of z2, 4 minus 1 is 3 divided by z3 minus with the inverse sine hyperbolic of 1 minus 1, which is 0. So the final answer will be 1.1514. How to use calculator to find sine, the inverse sine hyperbolic of, let's say, z2. So what you need to do is you have to click shift, then button HYP, and then button sine and square root and 2. Then you will get the answer. Now let us discuss the final exercise for the inverse hyperbolic functions. Given that you have to find the integrals of inverse cos hyperbolic x, where the intervals start from 1 to 2. Okay, this is a unique question because based on the formula, the antiderivative of du over square root of u square minus a square will result in cos hyperbolic inverse, but there is no integration of cos hyperbolic results in any solution. So in order to do this, we have to use the integration by parts, where integration by parts, the formula is uv minus v du. So in order to do this, you have to choose which one should be u and which one should be v. So to get this, for these questions, we have to choose u as the inverse cos hyperbolic of x, because when you choose u as inverse cos hyperbolic of x, then you can find the du over dx, where the du over dx of cos hyperbolic will be 1 over square root of x squared minus 1 dx over dx, which will be 1. So we can solve this cos hyperbolic. Okay, now what is left is dx. So our dx can be represented as dv, where dv is equals to dx. So v will becomes the integration of dx, or 1 dx, which is equals to x. Now we can solve the integrals of inverse cos hyperbolic x dx, where we use this formula. So we substitute u with inverse cos hyperbolic of x times with v, which is x, minus the integration of v, which is x, and our du is this. So our dx will be over here, x over square root of x squared minus 1 dx. Okay, now we try to solve the integration of this, where this is x over square root of x squared minus 1 dx. As you notice, it involves x over square root of x squared minus 1. So we can use the integration by substitution, where we let u equals to x squared minus 1. So now we have du, which is equals to 2x dx. Or we can write it as du over 2x dx. Okay, as you can see here, we have substitute this x squared minus 1 with u, and our x dx with du over 2. So the whole integrals are in terms of u now. So this is the correct one. So x dx is equals to du over 2 times with square root of u. Or if we rewrite this, it becomes u to the power of negative half du. So now we can solve this integration, where this is 1 over 2 u negative half plus 1, which will be half divided by half plus c. So we rearrange this. This will become 2 . Next, don't forget to substitute u with x squared minus 1, because we have represent u as x squared minus 1. So this will be half. Oh, this one can be cancelled out. So u is x squared minus 1 square root plus c. Now we have solved this second term. So we rewrite this. Now I rewrite the solution back. Okay, and I simplify all this. So the integral of inverse cos hyperbolic x dx is equals to this. Okay, the last step is to substitute the interval of 1 and 2 into x. So I will rewrite this. Cos hyperbolic inverse of x dx is equals to x times with the inverse cos hyperbolic x minus square root of x squared minus 1 by the interval start from 1 to 2. So this will be 2 cos of 2 minus 2 square is 4, 4 minus 1 will be 3, minus with 1 times with inverse cos hyperbolic of 1 minus 0. So by using the calculator, the final answer will be 0.9019.